Hello everyone. Actually, I don't know what the kind of policy the YouTube has to keep the censoring videos taken by me, but the video upload keep getting the stuck in the middle. So I decided to take it again. I don't know what the problem but this is our the really important promise, and I'm always do the keep our the promise. So I decided to take it again. But one thing is sure, that's not my part. Uh, the, the, During the 3 days, the videos, the upload keep getting the stuck in the middle on the 88%, 89% stuck. Okay, and these the answer sheet, or I'm previous the if I had some make this some and taking using the during the taking videos and using this the answer. So using this answer sheet and just read the sentence, and if there's some something important things that I little bit some marked using the some um, underline. So first ddx x to the 5 tangent x. So using the uh, derivative product rule. So f uh, f g prime equal f prime g plus f g prime. So 5x to the 4 tangent x plus x to the 5 times secant square x. Okay, number 2. So let the x over 2 equal to t, the 1 over dx equal to dt. So sub substitute the x to the x over 2 equal to t, the half ddt tangent inverse t equal to even 1 1 half 1 over 1 plus 2 square. So half 1 plus 2 square equal to, so the denominator and numerator is the half, and denominator 1 plus x square over 4. So answer equal to canceling the both denominator and numerator 2 equal to 2 over 4 plus x square. And number 3, ddx x plus cosine x plus y equals 3. So derivative is left side and right side, and y prime equal to 1 over sine x x plus y minus 1. Okay. Number 5. So the tangent inverse arctangent, both two things can be applied, can be allowed. So tangent inverse tangent inverse negative square x 3, or arctangent negative square root 3 is okay. Both two things are also okay. So arctangent negative 3 negative square root 3 equal to, here is the tangent x. So the here the negative square root 3. So there's two root. So here's the pi over 2, and here's pi, and here is 3 pi over 2, and here's 2 pi. So zeta 1 equal to pi minus pi over 3, and 2 pi minus pi over 3. So the from here to from here. Okay, so answer is 2 pi over 3 or 5 pi over 3, and zeta 2, here's the y equals sine x. So here is the arc sine minus square root 3 over 2. Also got a 2 root. So here is 2 pi. So, and here's sorry, here's pi. Wow. Here's 2 pi. So here going to pi over 3 and subtract pi over 3. So pi plus pi over 3 or 2 pi minus pi over 3. The answer is 2. And there's two real roots in this. So zeta 1, here's zeta 1 and here's zeta 2. And no 5. So we can canceling, it's okay to 4 over 5 equal to 2 over 4 divided by pi over 2. Okay, so it definitely okay because every fraction numbers means the ratio of two numbers. Okay, so the dy dx equal to dy d theta divided by dx d theta. Because we can cancel this d theta, so those two the fraction are exactly same equal to each other. So e to d theta sin theta d theta dy d theta equal to e theta sin theta plus e theta cosine theta, and dx d theta equal e theta cosine theta. You should be aware there's some signal because d dx of t d theta cosine theta equal to negative sin theta, so minus e theta sin theta. So canceling e thetas, sin theta plus cosine theta divided by cosine theta minus sin theta was put into the pi over 2, then 0 plus 1 divided by 0 minus 1 equals minus 1. 6. As shown in the following the diagram, so first, what's minimum length of the hypotenuse? So let the ax equal to x, and suppose angle CAB equal to theta, then AB are x cosine theta and BC are x sine theta, right? So the add our three segment and two legs and one hypotenuse, then x plus x cosine theta plus x sine theta equals 100. So x equal to 100 divided by 1 plus sine theta plus cosine theta. So sine theta plus cosine theta. Cosine theta means always there's x value. So here is the cosine theta. Here is sine theta, right? So sine theta plus cosine theta, and here's, and so cosine theta equal to 1 is 1 cosine theta, and here's the 1 sine theta is equal to 1 and 1 is suppose this triangle right angle triangle, so its hypotenuse square root 2. So sine theta plus cosine theta equal to square root 2 times sine theta plus here is the pi over 4. So sine theta plus pi over 4. So all sine thetas, sine theta should be larger than or equal to negative 1, less than or equal to 1. So square root 2 sine theta blah blah, that should be larger than negative square root 2 but less than square root 2. So think about that. Imagine then as getting the denominator are increasing, then that fraction getting smaller. For instance, 4 over 1 and 5 over 1 and 6 over 1. So as getting the denominator increasing, that fraction getting smaller. So I want some minimum length of the hypotenuse. So we should be we even though we want to some the minimum length of x, like minimum value of x, but in that means also maximum value of the denominator. So maximum value of denominator is 1 plus square root 2. So 100 divided by 1 plus square root 2 equal to 100 times square root 2 minus 1. Okay. And 7. Suppose the fx equal to here. So actually these are already some exercising some practiced during our school, our classes. So some function are differentiables. It means that at that point fx is continuous, and at right hand derivative and left hand derivative, two derivative equal to each other. So put the x equal to 1, then we can find b equal to 1. and the derivate, find the derivate. So f prime x equal to minus pi b sine pi x plus 2 and a divided by x. So put into x equal to 2 and a. So a equal to 2 and b equal to 1. Okay. And number 8. To find the minimum positive value of a such that the function fx blah blah blah. So some fx here is using the some trigonometric properties. So sine square pi over 2 equal to 1 minus cosine pi x divided by 2. So fx equal, we can sine square pi over pi x over 2 can be exchanging the negative half cosine pi x plus 1 half. So this is some from your the chapter 1 so reference near the calculus, Thomas calculus in chapter 1. Then you can find some trigonometric properties. Please reference that the trigonometric properties. So in these cases minus half the cosine pi x, then horizontal shrink. So usually cosine pi x, the period is 2 pi, but I'm told you fx is fcx. Then as a c, if the c is larger than 1, then horizontal shrink, right, shrink, and c is larger than 0 but less than 1, then in the cases horizontal shrink in this horizontal stretch, right. So c is larger than 1, pi is 3.14159 blah 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 like this. Anyway, so the minus half cosine pi x plus half equal to 2 pi divided by pi. So the period equal to a. Okay, so if you want that answer is right, then put into x equal a equal to 2, then fx plus 2 equal to 1 cosine pi x plus 2 and cosine 2 pi plus pi x. Cosine 2 pi plus pi x equal to cosine pi x. So 1 minus cosine pi x. So fx plus 2 equal to fx. Okay, so we can check it. The answer is right. Number 9. Blah 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 blah. So efx prime equal to f prime x efx. So using these properties, f prime x equal ex ex e to the 2x blah blah until the e to the nx, and denominator ex and 2 times e to the x, e to the 2x, 3 times e to the 3x blah 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 to the n times e to the nx. So put into x equal to 0, r e to the 0 equal to 1, then here's n 1 plus 1 plus 1 n times. So denominator is equal to 1 and numerator 1 plus 2 plus 3 plus n. So 1 plus 2 plus from 1 to plus to n, every terms getting add 1, then every increasing n terms getting terms increase by the terms increasing, add 1, then 1 plus 2 plus 3 plus blah blah like to n. In the cases, the n times n plus 1 divided by 2. So cancelling, the n plus 1 divided by 2 equal to 10. So n equal to 19. Okay. And from the 10 to 13, you shouldn't be missed that problems, cause all these four problems come from the AP calculus problem. So that's really easy. So 10. So using the quotient, derivative of quotient function, then h prime x equal to f2 prime times gx minus f prime x times g prime x divided by g square x. Okay, so put in x equal to minus x equal to 2, then h2 prime equal to 3 and g2 equal to minus 2 and f prime 2 equal to minus 3 and g prime 2 equal to 5 and f equal to minus 2. So the answer is 9 divided by 4, 11. So that is f prime. So just to check the sign here above the section are increasing because f prime equal to positive. You do not need to the value. What the value? 1 plus 1, 2, 3, 100. It doesn't matter if they're above some f prime x appears above the x-axis, then f is increasing. I don't mean f prime is increasing. Here is f prime is increasing, and from 1 to 2, f prime is decreasing. Even though from closed interval 1 to 2, in this section, even though f prime x are decreasing, but f is increasing. You should be distinguish f prime x and fx. Okay? Even though f prime x are decreasing, but from 1 to 2 in this section, f is still increasing because f prime x is positive. Okay? So it's positive, negative, and positive. The answer is here. So it means f prime x. Okay, but actually one of you, Park Jiun, I'm really sorry for him because he also this problem using the definition of the derivative. Actually, you do not need to using the definition of derivative to our problem. Yes, sometimes derivatives need lots of time. So if there's a condition, you should be using the definition of the derivative. In that cases, you can using some easy way. Okay, so that right the terms means f prime 1. So using the derivative over polynomials. So here is f prime x is 3 times x parentheses x squared plus 1 to the 1 square times 2x. Okay, so put into x equal minus 1 equal to minus 24 and 6. Left hand limit when x equal to 2 equal to 3. Okay, right hand limit fx equal to infinity. Okay, C, both two left hand limit and right hand limit does not equal to each other, so limit value does not exist. So the answer is C. 14. Oh yeah, right. Actually, none of you got this problem, but most of you almost closed the answer. Okay, so maybe most of you find this. So here, so let this equation equal to first equation and second equation, and this underneath this equation that second equation. So one equation minus second equation is here. So most of you are finding this, and then you have to stop there. Okay, so maybe actually in calculus just only two methods to solve the problem. First, derivative. Second, integral. So in these cases, you just only using the derivative. Okay, don't you? So if you think about, I think the most problem is come from your viewpoint. some cup and water in it on your the table in front of you. So am I right? It's a really famous story. So sometimes someone tell tells it's talk to some about the cup. Wow, there's a half of the water still there, and someone really complain. Oh, the half of the water already disappeared like this. So please, all this problem really easy. You can solve it. Then you can solve it. Okay. So think about it. This section, all this section come from the derivative. So, and other section come from the integral. But in these cases, it's just only one way. Using derivative right this. So let this equation is a third equation. Then derivative third equation and second derivative third equation. And so plus then 2 minus and so then this is a fifth equation. This fifth equation put into the second equation, then you can generate this sixth equation, ex e to the negative x blah 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 blah. So then fx ex minus 2 to the minus x, right? And final equation, sine 2x plus 2 sine x less than a. So that is our some project. So if you want to find some maximum and minimum value, there's few candidates are there. First, extreme value can be the maximum or minimum value and the boundary value. So find the extreme value and put in the some boundary x value into the fx. Okay, that is the candidate of the some extreme value. Okay, so f from x is 2 cosine 2x plus 2 cosine x. So 2 cosine 2x is 2 cosine square x minus 1. So 4 cosine 2 square x plus 2 cosine x minus 2. So this is looks like a quadratic function, right? So factoring, so cosine x half for the minus 1. So there's 3 roots, and so x equal to 5 over 3 and 5 over 3 and 5. So and the boundary and 0 and 2 pi. So find the 5 functions, and this x put into the here, not here. Here's f prime x and here's fx. So put into here, then fx equal to 0, f0 equal to 0, f5 over 3 equal to 3 times 3 square root to 3 divided by 2, f5 equal to 0, f5 pi divided by 3 equal to negative 3 square root to 3 divided by 2, and f2 pi equal to 0, right? So we can find some range of the fx. So minus negative 3 square root to 3 divided by 2, fx is larger than negative 3 square root to 3 divided by 2, but less than the 3 square root to 3 divided by 2. So I want to find the maximum, find the minimum constant a. So fx, fx, here's fx. So what is the minimum value of a? So fx can be sometime, for example, here's the minus 2 and 3, not exactly, just for instance. So in that cases, a can be 4, 5, 6, 7, it could be, right? So what is minimum value of a equal to 3? So the minimum value of a means maximum value of fx, right? So fx, so minimum value of a 3 square root to 3 divided by 2, right? Okay, thanks for watching my videos, and until the next Tuesday, you should be submit your the backup papers. Okay, have a nice day and see you.